Alright, here are solutions for perfect problem 4 from Math 112. In this problem, basic idea is you got three people starting out at the same spot, and they all go in different directions. One, who I'm calling, listen, maybe I should just read the question. Alex walks south. Fine, maybe here's south. And Chris walks east. Okay, so here's east right here. Brian takes the elevator up, so Brian goes up this way. So maybe I'll call this point right here B, this point down here A, and this point over here C. And I won't try to draw this to scale because frankly you don't need to, and three-dimensional is what I'm going for here. Kind of get weird with perspectives anyways. So the only thing I know is that Brian took the elevator up 25 feet. So from this point right here, which I don't know, call whatever you want, D I guess is as good as anything. I know that this distance, BD, is 25. So really what ends up happening here is I have a whole bunch of triangles. I have a right triangle ABD, and I have a right triangle BDC. Maybe I should label these a little better. So there in red is one right triangle, and here in blue is another right triangle. And then I have a third right triangle, ADC here. Okay, so let's go figuring out some sides. The first piece of information we get is that the angle of elevation from Alex up to Brian, so we're talking about this angle right here, is 30 degrees. So if that's 30 degrees, I have this triangle here, which maybe I can draw it a little bit better off to the side. And again, not to scale. But here's A, here's B, and here's D, and I know that this angle right here is 30 and that this side length is 25. And so what I'd really be interested in is the side length AD here. So maybe I'll call this length X. So what I'm doing here is I'm relating together the side length opposite this 30-degree angle and the side length adjacent to this 30-degree angle. So the trig function that relates together opposite and adjacent is tangent. So tangent of 30 degrees, which I can figure out off my unit circle, that must be equal to opposite 25 over adjacent, which is x. In other words, x must be equal to, if I multiply it up to this side, 25 over the tangent of 30 degrees. And so the tangent of 30 degrees, maybe I do that off to the side. Well, I know that's tangent is sine over cosine, so it's the sine of 30 degrees divided by the cosine of 30 degrees. And maybe you prefer to convert to radians. I'm not going to bother. I'm just going to say I know where that is on my unit circle, and the y-coordinate at this point is 1/2. And the x-coordinate at this point is root 3 over 2. And if I take 1/2 and divide it by root 3 over 2, that's equivalent to taking 1/2 and multiplying it by 2 over root 3. So I can cancel out those 2's and get 1 over root 3, which is typically not how I leave my answer. I want to rationalize the denominator, so I multiply the top and the bottom here by root 3, and that gives me root 3 over 3. So what I have is that x is equal to 25, so maybe I'll come down here now. So x equals 25 divided by root 3 over 3, which is 25 over 1 times 3 over root 3. Maybe it would have been wiser to use one of these unrationalized forms, but I've gone this far. I got this is 75 over root 3, or 25 root 3, I guess is what that ends up being. Multiply the top and the bottom by root 3, and you get 75 root 3 divided by 3. But the 75 and the 3 can cancel to leave you with 25 root 3. At any rate, I figured out x. Cool. That'll end up being really useful because of what maybe I need to label my picture here. I got x here. Really what the question is asking me about is the distance from A to C. So maybe I'll call that distance Z. And how am I going to figure out Z? Well, I got a right triangle here. I guess I should denote that it's a right triangle. The way I can figure out the length of a right triangle is if I know the length of the two sides. So now I know x. If I can figure out this side over here, I better give it a name. Maybe I call it y. And I think I can figure out y doing analysis very similar to what I just did. So maybe I do that over here. Now I got this triangle. It's again a right triangle. And it's Chris looking back up at Brian notices the angle of elevation is 45 degrees. which, let's see, that's enough to tell you that this is an isosceles triangle, and therefore y equals 25. You can immediately figure out y is 25 because it's isosceles. Or you can not realize that, which is fine. You can call this 45 here. You can label your sides. I guess this would be C, and this would be B, and this would be D. And I know that the distance from D to B is 25, and what I'm interested in is the distance from C to D. And so I could again use tangent because I want to relate together the side opposite and the side adjacent. So the tangent of a 45-degree angle has to be 25 over y. But the tangent of a 45-degree angle is just 1. So what I end up with is that y must equal 25. And maybe even parenthetically. Or because BCD is isosceles, which I don't know how to spell. I think that's about right. So now I know that y is 25. So I have x here and I have y here. When you read the question, it asks you how far apart are Chris and Alex, aka what is z? Well, I can figure out z using the Pythagorean theorem. I know that z squared has to be equal to x squared plus y squared. The square of the length of the hypotenuse of a right triangle is always equal to the sum of the squares of the lengths of their legs, aka a squared plus b squared equals c squared. But I don't want to use a, b, and c because those kind of denote the points in this problem, so I'll use x, y, and z. I got this equation here. Well, let's figure it out. X I calculated to be 25 root 3. Y I calculated to be 25. So what I get is that z squared is equal to, well, if I take this squared and hit each of the factors, I got 3 times 25 squared. And you can figure out 25 squared if you want. What is it, 625, I think? But I'm not going to bother doing that. I'm going to solve this a different way and say that I have 3 of these 25 squared things plus 1 more of these 25 squared things. So in total, I have 4 of these 25 squared things. So z is equal to the square root of 4 times 25 squared, aka 2 times 25, aka 50. So I doubt anyone does it this way. You probably pull out a calculator and figure out this is 625 and multiply it by 3 and get, what, 1875, and add to that another 625, and I think you'd get 2500. Take the square root of that number and get 50. But if you don't have a calculator in front of you, this is another way you can do it. At any rate, the answer to my question, how far apart are Chris and Alex? They're 50, whatever my units are, feet, I think, in this case. So I'll call that good.